All right, I'm going to go over quiz 3 carefully with all the computations correct. I took down what I had before. So I miss you guys, and I did grade everything, and some of you really need to go through this carefully so you understand, should understand it. Now, this is what I think the intent of number 1 was. It was probably to use the formula to make a judgment call whether this angle between the two vectors was going to be 0 or 1, or the cosine theta was going to be 0 or 1. So if you were going to do it computationally purely, the first thing you would do is compute u dot v. And since u dot v is not equal to 0, in this case it's 8, we know that they are not orthogonal. Step 2, okay, so that's perpendicular, orthogonal. I use the symbols perpendicular symbol and orthogonal symbol, or the parallel symbol. Next question was whether it was parallel. Better phrasing would be, are the vectors pointing in the same direction? And so for that, we need to compute the magnitudes. Some of you made this error that you forgot to put the parentheses down. If you forget the parentheses and you type it in your calculator, it's going to say -1 and then square it, which is -1. You want to square the entire -1. And so for the magnitude of u, I get square root of 5. For the magnitude of v, I get square root of 13. So when I take cosine theta, I don't get 1. And so they are not parallel, or better said, the vectors don't point in the same direction. Aiden, your section marcher, had a very clever way to do this problem. And in fact, I gave him full credit. I would give him extra credit if I could, because he really shows that he understands what's going on. So he plotted the two vectors, and I didn't do a good job plotting, but they are not pointing in the same direction, nor do they look orthogonal, perpendicular. They're clearly not perpendicular. So he just looked at it and said, well, they're not parallel or orthogonal. So he answered the question by just graphing it. And I thought that was a quick way. I don't know if he figured that out right away, but he understands what parallel and orthogonal mean, and he knows how to plot the vectors. So he did it all in one shot. That might not be easy if you have a three-dimensional, if you have 3 components, because then you'd have to graph these in 3D. But for 2D, it works beautifully, magnificently. One last way to see if they are not parallel or are parallel is that there's a theorem that says that two vectors are pointing in the same direction if and only if they are scalar multiples. So that means that the first vector, u, has to be a multiple of the second vector. Well, if I look at the first component, -1, the only way to get -2 here is if I multiply by +2. But if I multiply the second component by +2, I get 4, not 3. So there's not one scalar multiple that will make the first vector a multiple of the second one. So that's another way to see quickly that they're not parallel. That minimizes your computations, because then you could have just done the dot product, answered, and then checked the scalar multiplication theory. Number 2, the intent was there to actually do the computations and find the angle. So step 1 is to compute the dot product. You should have got -15. Step 2 is to compute the magnitudes carefully, making sure that your negative numbers are in parentheses. And you should have got 5 for the magnitude of A and square root of 10 for the magnitude of B. Then you just plug it into this formula. And so you get cosine thetas minus 0.9486832. I can tell you just looking at that formula, these are not parallel or are orthogonal, because it's not 0 or 1. But that was not the question. The question was to find theta, and you have to use the cosine inverse. So some of you seem hung up somewhere on the cosine inverse function. I don't use your calculators. I have my own stuff that I use. So I don't know what's hanging up on your calculator, but that's a task that you need to have 100% known before you go to the WPR. So you should have got 161.57 degrees. Note, the question asks you for degrees. My math loving heart doesn't like that, because we work in radians. Radians is actually the correct way to look at things. degrees is an invention. But whatever said, they asked for it in degrees. You put your calculator into the correct mode, degree mode. If you don't know how to do these things on your calculator, find someone who does. Final thing, you guys got tripped up on this matrix because the matrix multiplication was weird looking. It wasn't like a box. You just had a row, but you just run it through the machine. A few of you did this. I'm trying to think who did it. You just wrote out the size of your result right away. Since you have a 1, I know Dalen did it. So 1 by 2, 2 by 3, the answer should be 1 by 3. And so then you just do the computations, and I made extra room here so that you could see where I was getting everything. You take the first row and dot it with the first column, and that gives you your first component. You take the first row and dot it with the second column, that gives you your second component, and so on and so on. Now, if you had 2 rows in the first one, you would have an entire second row of stuff to do. But here, I think it was so simple that it tripped you up. You should have got 5, 11, and 17 at the end. So I'm sending out this PDF, and I'm also recording this video. My stylus is broken on my thing. It was already broken. I think you saw that in class. I got a new stylus. It's coming tomorrow morning. So if you do need help from me, until Monday, I will be available.